Well, hello everybody, and welcome back to another fabulous episode of Beau Maths. We are on part 24 of the Fundamentals of Algebra series. We've gone through a lot, and I'm proud of you for making it this far. What are we talking about today? Well, last video we kind of introduced fractions, we saw how we could simplify them, and we did some cool things with that. And today we're going to be continuing on the fraction journey, and I kind of mentioned that fractions and decimals are kind of two sides of the same coin and that I would be talking about that. Today we're not going to be talking about that directly, but we're going to be doing the lead up to it, and we're going to be motivating kind of the method that we'll be using to convert fractions to decimals, and then we'll look at that explicitly in the next video. But today we're going to take a little bit of a trip down memory lane and go all the way back to part 1 of the series where we were looking at all the sort of number line transformations that we could do. So I have a number line right here, and what I'm going to do is I'm going to divide this number line. So if you recall, that meant we were compressing the number line. Alright, so the method we did for that is we took a copy of the number line, which I have here, and then we compressed it. So let's say we divide this number line by 2. That means we're making the distances between all the ticks on the number line 2 times smaller, but we're always fixing 0, since 0 divided by 2 is still going to be 0. So we're making all these distances 2 times smaller. Alright, so then we see, okay, what do things line up with? Well, 0 lines up with 0, since 0 divided by 2 is 0. 2 lines up with 1, since 2 divided by 2 is 1. 4 lines up with 2, since 4 divided by 2 is 2. But then we also saw for some decimals, right? 3 lines up with 1.5 because 3 divided by 2 is 1.5. Or negative 1 lines up with negative 0.5 since negative 1 divided by 2 is negative 0.5. We also kind of use this to show that a negative divided by a positive is indeed a negative. So that's just a little bit of review for you. If you want to look at the full video, it'll be in the description as part of the prerequisites for this video. Well, now let's take a little bit of a different perspective, and let's just focus on a smaller portion. So I'm going to do it again, but this time I have just a bit more of a bigger number line from 0 to 2, and I've just focused on the 0 to 1 segment of our original number line, and I'm going to divide the number line by 2 again. So 0 stays put, and these distances become 2 times smaller. Now, what we notice is that we have essentially split the segment of 0 to 1 up into 2 evenly sized segments, right? We got the segment from 0 to 1, and we have the segment from 1 to 2. And if you recall from the last video, this was one way we used to visualize fractions on the number line. What this means then is that we see, okay, 1 would line up with a half, because that's how we visualize the fractions again, right? This is half the distance between 0 and 1, because again, we've split it up into 2 evenly sized segments, and this is like the first segment. And then 2 would line up with 1, but we could also think about that basically as 2 halves, right? And 0 we could think of as basically having 0 halves. If each of these portions represents how many we have out of 2, right, because of these 2 segments, this first part we've done none of the 2 segments, so we're at 0 out of 2. Then we've done 1 out of the 2 segments, so we're at 1 half. And then we've done all 2 of the segments, so we're at 2 out of 2, right? Where our numerator basically represents how many of each of the segments we have. All right, so let's try it again, but for 3 this time, and you might get a bit of a better idea about what's going on. So I've done it again this time, except this time I have in the copy the number line 0 through 3. And let's divide this number line by 3. So that means we're making all these distances to be 3 times smaller. And we know 3 is going to line up at 1 since 3 divided by 3 is 1. So what we have now is we've basically split this number line up into 3 evenly sized portions, right? So let's think about a denominator of 3. And again, if we're kind of considering putting fractions on here, then this first segment out of the 3 will be 1/3. This second segment out of the 3 will be 2/3. And this third segment out of the 3 will be all 3/3. And this first segment will just be none of the thirds. So 0 is in our numerator, so we get 0/3. So what have we done here? We've essentially used division that we've seen on the number line, right? Compressing the number line to obtain fractions. And this is the main point I want to drive home in this video. Fractions are just division, okay? 1/3 is just doing 1 divided by 3, right? We had 1 on the number line. We divided the number line by 3. 1 lines up with 1/3. So 1/3 is just 1 divided by 3. 2/3 is just 2 divided by 3. We had 2 on the number line. We divided the number line by 3. So we get 2 is 2/3. And then also for 1, we get 3/3, right? 3 divided by 3 is 1. In the last video, if we recall the discussion of equivalent fractions, I said things like 2/2 equals 1, 3/3 equals 1, 8/8 equals 1. These were all equivalent fractions, I said, and the way I showed it was by drawing like a pie, and I shaded all the parts of the pie in to show it was equivalent to 1. But we now also see with division, we know that any number divided by itself is 1, right? Now we get another perspective on why a fraction where the numerator and the denominator are the same gives us 1, because essentially we're just dividing them, and a number divided by itself is 1. But that's the main point of the story here. You can basically construct fractions by dividing, by compressing the number line into this segment between 0 and 1. So if we want to look at fractions that were 1/5 in size, then we would take the numbers 0 through 5, compress them into the segment from 0 to 1, and we would be good to go. Here we wanted fractions that were 1/3 in size, right? We want to get 1/3 and a 2. We wanted to get 1/3 and 2/3 for our fractions. So we took the numbers 0 through 3 and we compressed them into the number line of 0 through 1 using division. And we saw that that gave us 1/3, 2/3, 3/3, and 0/3, right? So we got those fractions. And we know that decimals lie between 0 and 1 like this, right? And we know that we can get decimals through division, right? If I did long division for 1/3, I'd be able to get a decimal, and so on and so forth. So in the next video, we're going to focus on how to do that to convert fractions to decimals, but then we're also going to look at how to do decimals back to fractions. So this was a bit of a shorter video, but I just really wanted to motivate as to why we're going to be able to use division to convert fractions to decimals, because fractions themselves are obtained through dividing these whole numbers and putting them onto the number line. So let's maybe do just one more example for the road. Okay, so here we're asked to construct 1/4, 1/2, and 3/4 on the number line using division. All right, so first of all, we need to remember that 1/2 is the same as 2/4, right? So we're just basically wanting to split our segment from 0 to 1 into 4 pieces. So we're going to do that by dividing the number line by 4. So again, we're just focused on the 0 to 1 part. We're going to get a number line going. All right, so we have 0 through 4 here. We're going to be dividing this number line by 4. Again, 0 is fixed, and 4 divided by 4 is 1, so we know 4 is going to line up at the 1. So compressing the number line, which is what division does, we get something that looks like this. And we know that we have basically split the 0 to 1 into 4 even segments. 1, 2, 3, 4. So each of these numbers will represent the numerator of that segment. We have 1/4 is right here because that's where 1 lines up with, and that's our first segment out of 4. So we have 1 out of 4 segments, that's 1/4. And then here, that's our second segment. We have 2/4 or 1/2. Here we have 3/4. And lastly, we'll have 4/4, which is the same as 1. So we just put these numbers on the number line, and we did it using compression to the number line. All right, so I hope you found that interesting, and I hope you found that to be just like a really fascinating use of something we did quite some time ago. I always think it's really cool when something you did a long time ago in math comes back, and that happens a lot in math. That's one of my favorite things about math, is that things you've learned before always seem to come back. So if you kind of keep it up, you're going to get a really full picture of what's going on. So just to recap, fractions are division. That is the biggest point to take home. We showed that by showing that we can get fractions by compressing the number line, which was division, right? And we're going to be using that fact in the next video when it comes to converting fractions to decimals and vice versa. So until then, you have a great day, you stay groovy, and I'll see you in that next video.